Now I want to prove a functoriality property for homology. So the context is like this. We have abstract simplicial complexes K, L, and M, and continuous maps P and Q, P from mod K to mod L, Q from mod L to mod M, and therefore Q composed with P going from mod K to mod M. And so we want to get from the homology of K to the homology of M. There's two different things we can do. We can have the map in homology induced by Q composed with P, or we can do it in two steps. We do the map induced by P from H star K to H star L and compose with the map induced by Q from H star L to H star M. And we want to claim that these two things are the same. So if we can prove that, that says that homology is giving us a functor from an appropriate category. We've got a category of where the objects are abstract simplicial complexes, and the morphisms are continuous maps between the geometric realizations of those complexes. Okay, so let's prove this. Okay, so this claim here involves Q lower star, which is a map from the homology of L to the homology of M. Now, let's remember how that's defined. What we're supposed to do is we're supposed to choose a simplicial approximation for Q, say M comma G. So G is a abstract simplicial map from L bracket M to M, and it's a direct simplicial approximation for the composite Q composed with beta bracket M. Beta bracket M is our homeomorphism from mod L bracket M to mod M. So all this can be displayed as down here. The left-hand diagram is a diagram of abstract simplicial complexes and simplicial maps. The right-hand diagram is a diagram of topological spaces and continuous maps. So here's the P and the Q that we were originally given. Here's our beta bracket M is a homeomorphism from L bracket M to L. And the idea is that G here is a direct simplicial approximation for this composite here. So in particular, the geometric realization of G is homotopic to the composite Q composed with beta bracket M. Okay, so that's what we do for Q and G. Now you might think the next thing to do is to just choose an arbitrary simplicial approximation for P. But it turns out that's actually not the most convenient way to proceed. Instead, we do something just slightly different. We consider, instead of P itself, we take the composite where we do P followed by the inverse of this homeomorphism here. We're looking at beta M inverse composed with P. So that's a continuous map from mod K up to mod L bracket M. And so we can do a simplicial approximation for that. So again, that's going to give us, this is the map that we're approximating, is a map from mod K to mod L bracket M. So the simplicial approximation is going to be from K bracket N to L bracket M for some N. It's going to be this F here. And so one of the key properties of it is that if we take this map that we're considering, P followed by the inverse of beta M, and then we compose it with this beta N, then that's going to be homotopic to mod F. Okay, so if we go this way, this way, this way, that's homotopic to mod F. And because these are homeomorphisms, that's the same as saying going this way around the diagram. It's homotopic to going this way, this way. Okay. So now I want to claim that G composed with F is a direct simplicial approximation for QP beta M. So let's just see where everything's happening here. So we've got G composed with F is this composite along here, and Q composed with Q composed with P composed with beta bracket N. That's this composite going down there and across there. And we want to claim that GF is a direct simplicial approximation for that. And that's true just because direct simplicial approximation is compatible with composition. So G is a direct simplicial approximation for this guy, and F is a direct simplicial approximation for this guy. So GF is a direct simplicial approximation for the composite, but when we compose this with this, then the beta bracket M here will cancel with the beta bracket M inverse there, just leaving us with QP beta bracket N. Okay, so GF is a direct simplicial approximation for QP beta bracket N. But that's precisely what we need to say that the pair N comma GF is a simplicial approximation for QP. Okay. So we've got our QP here, and then our GF across there, and this is the pair GF comma N is a simplicial approximation for this guy here. So we can use this pair N comma GF to determine what QP star is. right? You have to take the map induced by this GF, which is G star F star, and compose with the inverse of this mu n star. Okay? Remember, we proved that this mu n star is an isomorphism from the homology of k bracket n to the homology of k, so we can invert it, and so G star F star composed with that inverse is by definition what we mean by QP star. So now we want to understand about P lower star. So to do P lower star, we need to have a simplicial approximation for P. But remember, we didn't actually choose a simplicial approximation for P. We instead chose a simplicial approximation for this composite beta m inverse composed with P. But that doesn't matter so much, because we know, as one of our theorems we proved already, that mu bracket m is a direct simplicial approximation for beta bracket m, and also that f is a direct simplicial approximation for beta bracket m inverse composed with P composed with beta bracket n. Okay, so and direct simplicial approximations are compatible with composition. So we take composite of this with this. That is a direct simplicial approximation for the composite of this with this. But when we compose this with this, then the beta bracket m is going to cancel with the beta bracket m inverse, just leaving P composed with beta bracket n. Okay, so that's our conclusion here. Mu m f is direct simplicial approximation for P beta bracket n. Okay, and that's by definition the same as saying that the pair n comma mu bracket m f is a simplicial approximation for P. So yeah, so just looking again at that, what we've got in the diagram here, it's saying that if we take this f here, compose with this mu bracket m, that's a map from k bracket n to L, and that's giving us a simplicial approximation for this P here. So we can use this to understand what P lower star is. We have to do this, the map induced by this thing here, which is mu m star f star, and compose with the inverse of the map in homology induced by this guy here, which is mu n star inverse. And then Q lower star, well, that's just determined by this simplicial approximation that we've got here for Q. So the Q lower star is G lower star composed with mu m star inverse. Okay. So when we take Q star composed with P star, we're composing this guy here with this guy here, and then the mu m star inverse is cancelling with the mu m star. We get Q star P star is just the G star F star mu n star inverse, and that's the same as QP lower star. So that's the main thing we're supposed to claim. And also for functoriality, we should say something about identities, that the map induced by the identity is the identity, but that's straightforward. I won't give any more detail about that here. So this is proving that homology is a functor as claimed.